Okay, in this video I'd like to talk about the complementary angles rules, and you can see them there. They're in our textbook on page 267. So page 267, if you need to see them. So there they are. They're not on the information sheet. They've been known to come up in exams from time to time. So let's have a look at them. But first of all, some patterns. You might have noticed before that sine 60 equals cos 30 and cos 60 equals sine 30. For example, we probably know by heart now that sine 30 or sine pi on 6 is a half. And from our table we also know that cosine 60 is a half, and cosine pi on 3, which is 60 degrees, is also a half. So we might have seen that pattern already. And that pattern keeps on going. For example, sine 75, if we look at that, equals cosine 15. Cosine 10 equals sine 80. Can you see a pattern there? Can you see a relationship between those two? And if you're not sure, you can pause this video now and try them on your calculator. Switch your calculator to degrees mode, and you'll see that sine 75 is exactly the same as cosine 15. So what you're seeing there is that the sine of 90 minus a certain angle equals the cosine of that same angle. So if I go sine 90 minus, pick an angle, say 20, okay, that's the same as cosine of 20. Same thing, okay? So therefore sine 70 equals cosine 20. So that's how we start to develop these rules here. Okay, for first quadrant, you can see the rules I've already identified. Okay, there we go. Sine 90 minus an angle equals cosine of an angle. Cosine 90 minus angle equals sine of that angle. Now tan of 90 minus an angle equals cot of that angle. And I might just pause here for the moment and look at what's called the inverse trig ratios, which you may have seen before. And basically these inverse trig ratios are not a big part of our course, but they do crop up in a couple of places. 1 over sine theta, that is the inverse of sine theta, equals cosec theta. 1 over cos theta equals sec theta. And 1 over tan theta equals a thing called cot theta. Now, the way to remember these ratios is to look at the third letter. So you can see there cosec, third letter 1 over sine, sec, third letter c, 1 over cos, cot, third letter t, 1 over tan. That's an interesting way of remembering which one is which. Alright, so back to our rules. Go back to the previous slide. And you can see there, yeah, tan 90 minus theta equals cot theta. Now the rules continue on across into the second and third quadrant, but something to remember here is that, now what are the signs, positive or negative? Well, in the second quadrant, sine is always positive. So its equivalent value here, if you look at sine 90 plus an angle, is the same as cosine of that angle. But since sine is positive in second quadrant, it's a positive value. Here we got cosine, cosine in second quadrant is negative. So cosine 90 plus theta is the same as negative sine theta. Why? Because cosine is negative in the second quadrant. Same here with tan. Tan 90 plus theta, and remember 90 plus theta, if we go back to our cast diagram, okay, 90 plus theta puts us in the second quadrant. There's theta, and there's 90 or pi plus 2. That puts us in the second quadrant. So, in the second quadrant, tan is negative, so we get a negative value there. Third quadrant, sine now is negative, so sine 270 minus theta, so 270 minus an angle, puts us in here, in third quadrant. So sine is negative in third quadrant, therefore we get negative cosine theta. Third quadrant, cosine is negative, so we get negative there, sine theta, and tan is positive, so we get cot theta there, positive. So it's all got to do, whether it's positive or negative, it's all got to do with this expression here, the sine expression, cosine expression, or the tan expression. Because what they are in third quadrant determines what the equivalent is. So sine is negative in third quadrant, therefore the equivalent is negative. Fourth quadrant, so this is 270 plus theta. So if we go back to this situation here, 270 plus theta is going to put us in fourth quadrant. And in fourth quadrant, sine is negative. In fourth quadrant, cosine is positive, and tan is negative. Once again, pointing out the positive, negative, it's all got to do with this expression here. So it's equivalent, sine's equivalent will be negative because sine is negative in the fourth quadrant. Cosine's equivalent will be positive because cosine is positive in fourth quadrant. And tan's equivalent will be negative because tan is negative in fourth quadrant. So we end up with a whole heap of rules here. Now you probably don't have to learn them because what you need to know though is work out how the signs work. So if I pick one at random, I'll go over it one more time. Think about cosine 270 minus theta. We know that that's going to have an equivalent of sine theta. Is that equivalence positive or negative? Cosine is negative in third quadrant, so the equivalent is negative. So now we can do some problems with these. If sine theta equals 0.4 and tan alpha equals 0.6, find cosine pi on 2 plus theta. Alright, so let's look at that. I'm not even going to look up the rules here. I know that that has got an equivalent of sine theta. Is it positive or negative? It's negative because cosine is negative in the second quadrant. And remember, that is second quadrant. Pi on 2 plus theta is second quadrant. Therefore, it's negative sine theta. We know that sine theta is 0.4. Therefore, negative sine theta is negative 0.4. Tan 3 pi on 2 plus theta. That's 270 plus an angle. That puts us in fourth quadrant. What do we know about tan in fourth quadrant? It's negative. So we get negative cot theta. Now, cot, remember, is 1 over tan. So it's negative 1 over tan theta. Tan theta is 0.6. So it's negative 1 over 0.6, which is negative 1.667 if we work it out on a calculator. Okay, there's only one question in the book dealing with this. So it might be a good idea now to have a look at page 269. Page 269, question 10. Let's have a go at that.